Alright guys, so if you look at this entry test, they're asking you to find the sum or the difference. Now just as a quick reminder, what does it mean to find the sum between two different things? What mathematical operation are you doing to those things? Sum, right? What does sum mean? It means addition. That means when you take the sum of two things like 2 and 3, you're adding them, you end up with 5. So if you look at number 1, notice that you have something plus something. That means that you're finding the sum of those two things. Make sure that you associate the word with an action or an operation, because today it's going to be important, because that's literally what we're doing. We're putting names to things. So let's go ahead and add these. Now keep in mind that these parentheses are just there to kind of visually show you, hey, you're adding one of these to one of those. Now, the first thing that I always like to do is to make sure I distribute if there's anything in front of the parentheses. Now notice in front of these parentheses, there is nothing to distribute, so I'm just going to rewrite it over exactly the way it is, because there's nothing to distribute. There's no need for the parentheses for what I'm trying to do. Now notice that these parentheses over here do have a positive, but if you were to distribute a positive, you would end up with the exact same thing. So whenever you're adding two things, just drop the parentheses and start adding like terms. Now we talked all about like terms yesterday. The moral of the story is whenever you have like terms or combining like terms are literally things that have the same value that you could add. So when I look at all these here, I know that my answer has to be from greatest to least exponent. So I look at my variables that have an exponent of 2 because I see that that's my biggest exponent. And I look for other terms that have that same exponent of 2. And notice that I found one there. It's a positive 2x squared. So why did I circle those? Because again, those are like terms. They have the same values. They have x squared in them. Now what is a negative 1x squared combined with a 2x squared?
Three.
1x squared, absolutely that right. It's 1x squared. Now, this is a perfect opportunity to be practicing your positives and negatives. Even if you're not that confident in them, make sure that you're telling me, and I can try my best to kind of give you a quick lesson on how I like to do positives and negatives. So there we go. Those have been simplified because those are like terms. Those are the ones that you can add. Now, I'm going to go through and I'm going to see, okay, I have an 11x there. I can only combine the x's with the x's. Here's another x over here. So what is an 11x combined with a negative 5x? Well, that's just 11 plus a negative 5, which would give you a positive 6. Keep in mind, again, that your variables stay the same because you're just adding 11 x's minus 5 x's, you'd end up with 6 x's. These technically have been combined, so I'm going to go ahead and do the constants. I have a positive 13 and a negative 23. Now notice that those are just constants, so you would end up with a negative 10, absolutely right. Now notice that I cannot combine these terms because that's an x squared, that's an x. Those are two different values. And same thing with that constant. So that means we're pretty much done. That's as simplified as it could get. We have now found the sum. All right, Mike, let's sure we're paying attention up here, especially because you were absent yesterday. So if I look at this one, I can see that I'm finding the difference. How do I know I'm finding the difference? Because there's a very obvious subtraction sign between two parentheses. That means you're subtracting. Now notice there's nothing to distribute in front of these parentheses, so I'm just going to do exactly like what I did before. Just rewrite it over and go on to my next one, to my next parentheses, which I notice I have a negative. Now this is why I always kind of start with the same process. Distribute whatever's in front of the parentheses. Now notice there that you have a negative. So when you distribute a negative, it really just changes the signs to anything. A negative times 7x is a negative 7x. A negative times a positive is just a negative. And then a negative times positive is also a negative. So you'll notice there that I'm subtracting everything, so it really is just changing the signs of each and every single term that follows. Now, just like before, let's kind of see what terms we can combine. Because again, you can only combine the terms that have the same values, or the same x's, the same x squares, the x's, and so forth. What I like to do is underline everything that's separated with a plus or a minus, so that way I can focus on each of the terms, and then I kind of focus on which ones are the same. Like, for instance, the x squareds. You have a 4x squared plus a negative 3x squared. If you were to combine those, you'd end up with a positive 1x squared. Notice you have a positive 5x minus a 7x. Those are the next like terms that kind of stood out to me. 5x minus 2 is a negative 2x. And notice your negative 1 has nothing to combine with, but it's still going to be following along. So that is what I end up with. X squared minus 2x minus 1, and that's it. Okay, that's pretty much it. So again, what we're literally going to do today is figure out how to name these. Now there are special mathematical names that you have, and we're going to go into detail on how we name them. Now, before we go though, I want to kind of explain what makes this a polynomial. Polynomial is a fancy word for something that's not too complicated. And then I want to tell you what standard form is. The good thing is you've already been working with these, so these are going to be a little more straightforward. And then when we name them, we start giving names to these, they even become a little bit more because you'll notice that it's naming. You just got to know how to name things. So what we've been working with the last couple of days are what are called polynomials. And a polynomial is literally just an expression consisting of many terms. So I highly recommend that you write down these vocabs because you're going to have a vocab quiz on these things. Probably a small quiz that's following Tuesday. So just to reiterate, a polynomial is an expression that is just consisting of many terms. The way I like to kind of think of terms is that they're just things. That's all they are. So if you have a 5 is a thing. That's a polynomial because it consists of a thing. Now let's say we have x squared plus 1. That is also a polynomial because it consists of two things. There are two things that are getting added. And this could go on forever and ever. There could be a lot of different options. You can have something like 2 raised times x to the third power plus 5x plus 1. This is a thing plus another thing. So again, these are all examples of polynomials. You'll go into greater detail in algebra 2, but for the most part, I just want you to think of these as an expression consisting of many terms. And terms are what I like to call things. You'll hear me say that quite a bit often as we move forward. Now, this is what a polynomial is. It's an expression consisting of many terms. Now, in order to have a polynomial in standard form, the polynomial must be written with its exponents from greatest to least. So we've already been practicing this from yesterday. Again, all we're doing today is practicing what we learned yesterday, but we're actually putting names to it. You already know how to add and subtract polynomials. You've already done it in the entry task. Now you're going to also put polynomials in standard form. Pretty much have each of the terms in order from greatest to least in terms of their exponents. And that is pretty much all we're going to do for now. And then we're going to add a little bit to it. But again, you're doing everything that you've done. So you'll notice that if you were here yesterday, it seems like you're doing the same thing, just putting names to it. All right, so let's look at all these. Notice you have 6 examples. I'm not going to have you do the last 2 just to save some time. What I want you to do is I want you to write each of the following polynomials in standard form. So again, what does it mean to be in standard form? Is that the terms are in order from exponents to greatest to least. So if I show you number 1 here, is number 1 a polynomial? And the answer would be yes, because you have something plus something plus something. Now, if you look at each of the somethings, you have to know what the exponent is of each of the somethings. Let's look at this one. Look at this variable. What is the exponent of that variable? A 1. Now look at this 1 here, this physical number 1. It doesn't even have a variable. So what it would be, its exponent. A 0. Now look at this thing here. What is the exponent to that variable? 2. So is this polynomial in standard form? No, because again, the exponents are not from greatest to least. What would be the greatest exponent? It would be a 2. So that means that this term needs to go forward, 2x squared. Now keep in mind that I could have carried the positive, but there's no reason to have it positive because there's nothing in front of it. Now what I like to do is after I move it, I cross it out. Now which one of these has a greater exponent, the 3x or the what? The 3x, right? So that means that that goes next. But keep in mind that there is no symbol, or no operation. So I like to include it with a positive. So there's a positive 3x, just to say that I'm adding it. And you see that all that's left over is a positive 1. So notice that now I have my polynomial in standard form because I look at all the things are in order from greatest to least in terms of exponents. If I were just to kind of reiterate a couple things, keep in mind that if you have a number, a constant, your exponent is really a 0 because you don't have a variable. If you don't have a variable, that means it's getting raised to 0 because anything raised to 0 is 1. So that's the pretty much the general idea of it. I want you to try number 2, 3, and 4. I feel like that should be enough to get the general idea. So try 2, 3, and 4. I'll go around, try to clarify and answer any questions for you guys. So when you look at these problems and then they tell me to put this in standard form, and again, the biggest thing with students and everyone in general is that they don't read directions. So you have to make sure that when you read directions, you're understanding what the directions are telling you to do, because again, there are directions by definition. So notice here that we have a polynomial that they're asking us to put in standard form. Now remember that when you have a polynomial, you have a expression consisting of terms. Those terms are what I like to call things. Those things are what are getting added and subtracted. So notice I have a k squared. It is getting added to 64, which is getting subtracted by k, which is getting added to 7k to the third. So what I like to do first is write a line underneath everything that's separated by a plus or minus, because if it's getting separated by a plus or minus, it is its own term. So notice here that you have 4 terms. Now, if you look at this first term, notice that you have a variable that's getting raised to the second exponent. That means that the biggest exponent of that term is a 2. Notice that this 64 doesn't even have a variable. So what is its exponent of that term? 0. Absolutely right. And you need to train your mind that when you see a constant, a number like 64, that means it has an exponent of 0. Now look at this one. This term does have an variable, but what is its exponent? A 1. Because remember, if you have a variable and nothing's there, it is a 1. How about this one over here? 3. So if you look at this polynomial, is it in standard form? The answer would be no, because notice that the exponents do not go from greatest to least. This is a 2, a 0, a 1, and a 3. You need to rearrange it. Now, which one of these should go first? 7k to the third. Now, keep in mind that the whole term gets moved. Now, what's my next biggest one? It is a k to the second power. Now, keep in mind that there is no sign out in front. So it is a positive. It's a positive. You're going to be adding it. So it's a positive k squared. What's my next one? Notice it's a negative k. This one does have a sign because there's that negative. So I'm going to include it in my response. And then notice that you have that positive 64 left over. So that's literally how you just put it in standard form. You just have to be able to recognize the terms, recognize the exponents of each term, and then be able to organize it in a way. And that's pretty much it. If you look at this one, again, this is what I do to kind of slow me down and make sure I'm focusing on what needs to be focused. Yes, sir.
So on number 4.
Let's start with number 3, and then we'll go on to number 4, okay? So if you look at number 3 right over here, I underlined all my terms. I'm going to go back and I'm like, okay, what's the exponent of this term? I can clearly see it's a 3 because my exponent is a 3. If I look at my second one, I can see that the exponent here is a 2. So it's a second. Notice that the third one is a 28. And again, there's no variable. So what is the exponent technically? 0. And notice you have a variable here. If it's not written in a variable, a letter, it is going to be a 1. So notice here that the first two are actually in order because the biggest exponent is a 3. The next one is going to be a 2. And then notice that the 1 has to go first. So I'm going to move all that one over. What I mean by all that is the term, followed by your 28 at the very end. So now it's in standard form, and I can go ahead and do the next one. So let's just keep doing the same thing. These are all terms. Again, how do I know they're terms? Because they're separated by a plus or a minus. What would be the exponent of this 24? 0. What would be the exponent of this term? 3. And then this one would be a 1 because, again, if it's not written on a variable, it is a 1. So what do you guys think about order? Which one should go first? Negative n to the 3. Now, what should go second? Positive n. Now, what should go third? Obviously, it's the 24. Now, keep in mind that you can't just write the 24. You have to write a mathematical operation. Now, is that 24 positive or negative? It is positive, so you got to make sure that you tell the reader, hey, man, this is getting added. All right, any questions? All right, so if I were to tell you, hey, look at this polynomial, you know what I'm talking about? If I told you to put it in standard form, you know what I'm talking about. Now, what we're going to do today now is, or what we're going to do now, is that we're going to start naming these polynomials in a very specific way. And there are two ways that I'm going to ask you to do it. One of them is by the exponent. So I'm going to tell you to look at a polynomial and look at the biggest exponent. Given the biggest exponent is going to be the name of a specific polynomial. And then I'm going to tell you to also classify it or tell me what it is or name it by how many terms they are. So let me repeat this. There are several ways of naming things. When it comes to polynomials, the first one I'm going to have you do is by looking at each of the exponents. If you know how to find the biggest exponent of a polynomial, you know how to name it by degree. The second thing is how many terms that specific polynomial has. Now, before I actually show you examples, I want you to write down this list because it is how we are going to name them. So just like there's a lot of polynomials. If I tell you to look at a polynomial, you look at all the exponents, and the biggest exponent that you see is a 0, then that means that I want you to call that polynomial a constant. Now let's say I give you a new polynomial, and you look at all the terms, and you look at the biggest exponent it has, and the biggest exponent it has is a 1, then that means I want you to call that a linear polynomial. Now, I think you're getting the point, but let me make sure I repeat it one more time. Let's say I give you a polynomial, and you look at all the terms, and you look at all the exponents, and the biggest exponent is a 2. I want you to call that a quadratic. Now, if I give you a polynomial, and you look at all the terms, and you look at the biggest exponent, and you see the biggest exponent be a 3, I want you to call it a cubic. Now, last but not least, if you look at that polynomial and the biggest exponent is a 4, we're going to call that a quartic. Now, in this class, I'm not going to give you anything bigger, so these are the only ones that I want you to worry about for today. Now, notice there that what I said each time is when I give you a polynomial, it's your job to find the terms and to find the biggest exponent. When I tell you to classify something, it's telling you to name it. If I'm telling you to name it by degree, your first thought should be exponents. That should be your number one. Hey, if this guy's asking me to find the degree, he's telling me to find the biggest exponent. After I find that biggest exponent, I'm going to look at my list to name it whatever I want to be in that situation. Now, that ain't the only way I want you to name something. I also want you to name it by the number of terms, the number of things that are getting added within a polynomial. If you have one term, I want you to call it a monomial. If it has two terms, like there are two things getting added together in that polynomial, I want you to call it a binomial. If it has three things getting added, I want you to call it a trinomial. Now, luckily for all of us, anything 4 or more is just called a polynomial. And that's it. So if you can look at a polynomial and find its biggest exponent, and you have this list that you will memorize by the vocab quiz next Tuesday, you'll know how to name it. If you know how to look at a polynomial and know how to figure out how many terms there are within a polynomial, you know how to figure out how to name it in terms of its terms. Yeah. Did everybody get a chance to write down this list? I don't want to make sure to skip it. Denise, you're good. So notice I gave you 12 problems, and I'm asking you to name them by their degree and their number of terms. Now, this is what I like to do. The first thing I like to do is the degree. Now, if I notice here, I don't even have a variable. So what is the exponent when you don't even have a variable? Huh? Would it be 1 or 0? It'd be 0. It'd be 0, absolutely right. So if you have a 0 exponent, what do we call that? A constant. Now, how many terms are getting added here? Technically none, so how many things do you have? 1. So what do we call something with just one term? So this is what is called a constant monomial. Now notice that number 8 does have a variable. And what is the exponent of that variable if it is there? A 1, right? It's an exponent of 1, which makes it a linear, just like you said. Now, how many things are getting added? 1, so that means there's one term, so this is also a monomial. So if you look at these two examples, notice that one is a constant monomial, one is a linear monomial. And you should be able to work backwards too. If you see a monomial, you should be like, oh, there's only one term. If it's constant, that means that there's really no variable. If it's linear, that means it has a variable with an exponent of 1. Now, if you look at number 9, notice that you have 2 terms. But before we start talking about terms, let's figure out what the degree is. What is the degree of this first term? How about this one? So what's the biggest exponent? 1. So what is this overall polynomial? Now, how many things are getting added? So that is a binomial. And of course, you do have to make sure that you know what is degree and number of terms. It's up to you which one you want to do first. I always do the number of terms because it's easier to find. 1, 2, 3. Well, if it's a 3 terms, that means it's a trinomial. And then I go back and then I figure out the degrees. This has a degree of 2, a degree of 1, degree of 0. The biggest degree is 2, so that means that this is a quadratic. So find out what makes more sense to you. What helps you save some time in finishing these problems? So if I look at this one, I notice I have 2 terms. That means it is a binomial. Now notice that this is a degree of 3. This is a degree of 0. Biggest degree is 3. So that means it's cubic. Now if I look at this, I have 1, 2, 3, 4. What do we call something with 4 terms? Exponent of 4, exponent of 2, exponent of 1, exponent of 0. So it would be a quartic. And that's it. So we are going to practice today exactly what we practiced yesterday, adding and subtracting them, and then also naming them. So if you can name them, you can add and subtract them. You know exactly what you need to do.
Can you go back to that chart?
Yeah.